Welcome once again. Here we're going to look at Avogadro. Okay, Avogadro number. As I said, that one mole of a substance is equivalent to Avogadro number. Okay, the same way that just as you know that 1 dozen of pen, 1 dozen of anything, or maybe 1 dozen of pen is equivalent to what? 12 numbers, 12 numbers of pen, right? Okay, they say one crate of egg, one crate of egg is equivalent, one crate of egg is equivalent to what? To 30 pieces or 30 numbers of egg. So that same way, if they say one mole, if they say one mole, one mole of a substance, one mole of a substance, okay, one mole of a substance. Just know that one mole of a substance is equivalent to what is called Avogadro number. So you have to now ask yourself, this Avogadro number of a thing, what is the value for it? The value for Avogadro number is what? 6.02 times 10 to the power of 23. Do you get now? That is the value. And the unit is, if you want to write it, just know that Avogadro number is, the value is 6.02 times 10 to the power of 23. Right? The value, the unit for it is particles per mole. Like every 1 mole contains these particles. You get? So if you are looking at it with respect to either atoms, since we have already known the fact that particles or entities can either be atoms or molecules or ions. So if you want to be specific with respect to atoms, you are going to say the Avogadro number is equivalent to 6.02 times 10 to the power of 23 atoms per mole. What does it mean? In every mole, these are the number of atoms that is contained. Or you can say in every mole, these are the number of molecules. That is times 10 to the power of 23 molecules per mole. It means that in every mole, these are the number of what? Of molecules that are contained there. You get? Okay. Then the same thing goes for ion. On the aspect of ion, it also means that, okay, in every mole, if you want to be specific with respect to ions, you can say these are the number of ions that are contained in 1 mole of a substance, if they are talking something with respect to ions. So if they are talking with respect to atoms or molecules or ions, just know they are being specific. But if they are being generic, that is generally speaking, they are talking about particles in general, like they are generalizing everything, or entities in general. Okay, just know that the unit should be 6.02 times 10 to the power of 23 particles. It's either you say particles or you say entities per mole. Do you understand? Okay, so let's go to the next aspect. I told you guys that there are actually 2 aspects of stoichiometry, right? The reason I'm doing this video is so that you can understand it the more. I've explained it in my last class. There are 2 aspects of stoichiometry. 2 aspects of stoichiometry. Okay, the first aspect is what? Stoichiometry of composition. The first aspect is what? Stoichiometry of composition. stoichiometry of composition. Then the second aspect is what? Stoichiometry of reaction. Okay, so what does this guy mean? What it means is that it's a kind of stoichiometry that involves only one chemical substance. Only one chemical substance, right? Okay, then when you come to this one, what does it mean? What does this one mean? What does this one mean? This one means the one that contains more than one chemical substance, like two or more. Sorry, it contains two. It contains two or more chemical substances. Two or more chemical substances mentioned there. Okay? So in this kind of thing, we are going to first of all look at stoichiometry of composition. Stoichiometry of composition. So this stoichiometry of composition, I told you, is the one that involves only one chemical substance, right? Only one chemical substance. How do we tackle it? Just know that whenever you are given something like this, let me say, okay, compute, let me say you are given this question, compute the number of moles. Compute the number of moles present. Compute the number of moles present in 25.0 gram of sodium chloride. Remember, yesterday I told you guys that sometimes the chemical substance, they might write it in form of a name. Sometimes they might write it in form of a chemical formula. Do you get now? Okay, so if they write it in form of a name, whether IUPAC nomenclature or old name, you should remember the chemical formula for that. Chemical formula for sodium chloride is what? Sodium chloride, NaCl. Okay, and maybe they gave you something like this in bracket. Na is equal to 23, Cl is equal to 35.5. What are you going to do in such a case? First of all, ask yourself this question, this particular question that they gave us. Is it a stoichiometry of composition or that of reaction? Is it a stoichiometry of what? Is it a stoichiometry of composition? So once you know that something is a stoichiometry of composition, the next thing is asking yourself, which formula are you going to use and solve it? The formula we are going to use and solve it is what? Is you have to know it from the basic formulas I started treating yesterday, of which I'm going to emphasize the first formula again. Okay, I'm going to emphasize on the first formula again, the first basic formula. I mentioned it yesterday. The first basic formula, of which I say that n is equal to x over mwt. I'm going to emphasize on it again. Then I mentioned also the second basic formula. This second basic formula, remember I said that the second basic formula is the one whereby you say, okay, for a substance or for a chemical substance with a provided concentration, molar concentration and volume, right? Okay, in such a case, you have that n is equal to C molar times volume. Do you get? C molar times volume. See you in the next video.